Hello students, as you all know we are completing the course of integral equation. So before moving on to the solutions of integral equation, we must know the classification of integral equation, because for every different type of integral equation we have different methods to solve. So if you will not know the classification, you will not be able to figure out which method you are going to use to solve any integral equation. So classification of integral equation, before moving on to that, you must know what integral equation is. An integral equation is a kind of equation in which the unknown function, here u of x is the unknown function, in which the unknown function appears under the integral sign. Now this is the general integral equation. H of x times u of x is your unknown function here. This one is unknown function that we want to find. Basically, in finding the solution, we are finding this u of x. This f of x is basically a term that is making up your any integral equation, the homogeneous or non-homogeneous. This is your which part? Non-homogeneous part. This, if f of x is present, then this is your non-homogeneous integral equation. And if f of x is absent, f of x is 0, then this integral equation will be your homogeneous integral equation. Alpha of x and beta of x are the limits of integration. K of xt is the kernel of integral equation. U of t is your unknown function. Now, in the classification of integral equation, we have two main types of integral equation. The first one is Volterra integral equation. The second type is Fredholm integral equation. Now what are these? If your upper limit is a variable and the lower limit is constant, if your lower limit is any constant term, like you see these are the variables of x, but if your lower limit is constant and upper limit is a variable, then this is your Volterra integral equation. While in Fredholm integral equation, your both limits are constant. Both limits are constant. So this is basic difference between the Volterra and the Fredholm. If both the limits are constant, like if I'm writing up like 2 to 3, they both are constants, then this is your Fredholm integral equation. And if I'm writing like 2 to x, then this is your Volterra integral equation. Now within these two types, you have further types that is said to be the first kind or the second kind. So Volterra integral equation of first kind, and you have here Volterra integral equation of second kind. Now what is this first kind and what is the second kind? If there is only one time this unknown function under the integral sign and there is no other u of x in your equation, then this is your first kind. Like here your h of x is 0, then this thing completely disappears. If u of t is only under the integral sign and nowhere else, then this is your first kind. So in your first kind, your h of x is 0. So you will have here the equation of the type like this. The unknown function is only under the integral. But if your unknown function is present other than the integral, then this is your second kind. Like you also have here u of x equals to f of x plus integration from a to x, k of xt, u of t, dt. Same is the case here with the Fredholm. You have here in the Fredholm the Volterra integral equation of first kind and Fredholm integral equation of first kind, and you also have here Fredholm integral equation of second kind. In the first kind, the u is only appearing under the integral sign. And in the second kind, the u will appear under the integral sign and also other than the integral sign, like this. You can see here, in the first kind of Fredholm integral equation, there is only one unknown function under the integral sign. While in the second kind of Fredholm integral equation, this unknown function is appearing under the integral sign as well and other than the integral sign as well. So I hope you understand this classification. This classification is very useful in solving up the integral equations. So we will move on to next time to the solutions of Volterra and the Fredholm integral equations.